Hello students, today topic is linear magnification. So what is the linear magnification? It is the ratio of the length of the image I perpendicular to the principal axis to the length of the object. As simple as that, it is the ratio of the size of image upon size of object. Symbol is small m. And second way to find out the linear magnification, V upon U. V as a distance of image from the lens, U as a distance of object from the lens. Next study we will do for a different, there are two types of lens, convex lens and concave lens. So we will study the linear magnification regarding the convex lens. Further, convex lens make both the images, real images as well as virtual image. So for real image, magnification negative. Why? See here, in real image I will be negative, O will be positive, net answer negative, whereas in real image V is positive, U is negative, so net answer again negative. In short, for real image magnification is negative. For virtual image, I is positive, O is positive, remains answer positive. V is negative, U is negative, so answer will be positive. So virtual image magnification always positive. Now come to the concave lens. Concave lens always form the virtual image, so magnification of concave lens always positive. Second important note, with the help of the value of the magnification, how we will find out the size. If magnification greater than 1, then image will be magnified. Obviously, I will be greater than O, then answer will be greater than 1, image size will be greater, so that's why image is magnified. If M is less than 1, image is diminished. Obviously, I will less than O. M is equal to 1, I is equal to O, that means image is same size. So next topic is power of lens. So what is the power of lens? When the light passes through the lens, it will deviate the path of the light, means refraction occurs. So up to which limit lens can deviate the path of light, that is called power of lens. See the definition. Deviation of incident ray produced by the lens on refraction through it. Obviously, as simple as that, how much lens can produce the deviation in the incident ray when refraction occurs, so that is called power of lens. Next question, how power of lens is measured? So power of lens we can measure in the form of focal length. So what is the relation between power of lens and focal length? Obviously inversely proportional. So power of lens we can measure in diopter. Diopter spelling is symbol capital D. But one thing should be noted down, focal length should be, you have taken meter, only then answer of power of lens will come as diopter. For convex lens, power of lens always positive. Why? Because focal length of convex lens is positive. Power of lens of concave lens is negative. Why? Because focal length of concave lens is negative. So wholly and solely power of lens depends upon the focal length. Next topic is magnifying glass or simple microscope. In lower classes in geometry box, there is one small lens. What is the function of that lens? To see the small object in bigger size. So today we will study that magnifying glass. That glass is nothing, that is the convex lens. So in this case, convex lens, which case studied we? That is the last and sixth case in which virtual, magnified and erect image is formed in case of convex lens. So that is the case when object kept between O and F. So AB as a object. So one ray passes through parallel to principal axis, passes through focus, other is optical center. When you will extend it forward, it will not meet. Obviously, we will extend it at the back. So in that case, virtual, erect and magnified image is formed. So next is, on the basis of this, we will find out its magnifying power. For magnifying power, formula is 1 plus D upon F. F, as you know, focal length. D, what is the D? D is the least distance of distinct vision, means minimum distance with which we can see the object clearly. So that is approximately 25 centimeter, means the distance between lens and the image should be approximately 25 centimeter. When you will observe the object or the word, small word, at least distance in the distance between your lens and the image is 25 centimeter. So again, concentrate on this formula. Here is 1 plus d upon f. So magnifying power inversely proportional to the focal length. So if focal length will be less, magnifying power will be more. If focal length will be more, magnifying power will be less. So how can you increase the focal length? By increasing the thickness of the lens. So next topic is determine the focal length of the lens. I just explained one topic or one method in your book, that otherwise there are 2 or 3 methods. So what you have to do experimentally, you have to take this optical stand. On that optical stand, we will fix one side mirror, other side lens, and there is one sharp needle. What we have to do? We have to change the position of the needle till the particularly inverted image is formed on the tip of the needle, and you will observe this image from this mirror. Otherwise, sometime image is formed here, sometime here. We have to adjust the position of the object so that image is exactly above this object. When image is exactly above this object, definitely object is fixed at the focus of the lens. See here how. If image is formed here, now we will understand the mechanism of the formation of this image. Suppose your object is at focus. Ray come from focus, strike on the lens. After refraction, it will be parallel to principal axis and it will strike normally on the mirror. When it will strike normally, it will reflect back in the same path. So when any ray parallel to principal axis, after refraction, it will passes through the focus. That means this ray retraces its path. Same way, this ray will retrace its path. So obviously, when object that focus only, then image is formed at focus. When this position is occurred, then we will consider this distance between lens and the object is its focal length. In this way, we can find out the focal length of this convex lens. Next, last topic, differentiate between convex lens and concave lens. So you are provided with 2 lenses, convex and concave. How you will identify which one is convex and which one is concave? For that, we had 2 methods. One method by touching. You know convex lens is thicker in the center and thinner at the edges. You touch it. If that is thicker in the center, then this is a convex lens. If it is thicker at the edges, this is a concave lens. Second, by seeing image. So you simply keep the lens on the object and observe the image. If image is magnified, virtual, erect, then this is the convex lens. If image is diminished, virtual, erect, that is the concave lens. So in this way, you can distinguish between convex lens and concave lens. Hope you will study thoroughly. If you have some problem, you can ask to me, and you can definitely mention your name, class, and comment, especially in the comment box. Thanks.